this.
Yeah, what is that profile picture, dude? What? Silver?
Yeah.
Surgeon Silver, dude?
Yeah.
Oh my god, dude. That's too funny, dude. It's too
God,
funny,
are you
bro.
positive?
Am I what? Am I positive? What's up, Sam?
Yeah, are you positive?
Grim just said he has HIV and like keep that TP away from him. I'm like, no.
I heard it does. HIV positive.
Are you HIV positive? That's not, dude. That HIV sucks. Don't get HIV, please.
Exactly.
You like die.
Well, oh my god, bro. I got a lot to do today. And I've had a lot to do today.
I
Okay, so
have
first,
a lot to do. Okay, yeah. Tell us, Grim. Tell us about your day, dude. What happened?
First, in English, I have to do a project, which I have to finish today, later whenever I can, because my partner has not done jack shit.
Yeah, dude. That's the problem with partner activities, dude. Often, like, you get someone who's just a fucking bum, dude. They don't do anything.
I've done all the work so far.
Yeah.
Number two, I literally have in algebra 2. I was just learning a lot. Like I was tired mentally. I cannot process that shit. Number 3, I had to eat today. Yeah, it sucks. My calves hurt. Number 4, when I had to my body just hurt from having to be on the bus for like 1 hour and 30 minutes.
Why are you on the bus for an hour and a half, dude? That sucks.
Go home. That's it. Why else would I?
Why can't Ramiro drive you home? Doesn't Ramiro have a driver's license?
They took it. My mom and dad took his car. They were driving in it.
What do you mean they took his car?
Like they're using it.
Oh, okay. They didn't just like
No.
take it because he did something bad, right?
No, he hasn't done anything bad. Like
Oh, that's good.
me.
Okay, cool. Nice.
Yeah.
All right. Sweet. That's
Dr.
nice.
Gold.
What's up, Quadingle? How the fuck do I pronounce your name, dog? What's up?
Long way to go.
Can you guys teach me how to do resonance structures?
Yes,
'cause
bro.
I heard this is, like,
Yeah.
yeah.
Can you?
It's
So
Quandale Dingle. It's
Quandale
Fortnite
Dingle. I like that, dude.
Yeah.
Quandale Dingle. Okay. Quandale Dingle. Oh, dude,
Something
Sam,
like
dude,
that.
thanks for the sub, dude. 13 months. That's sick. All right, Quandale Dingle. Do you see there's a channel above called Help Screenshots?
Oh, help screenshots? Yeah.
Do you see that? Can you post a screenshot or a picture of one of an example questions that you need help with that involves resonance structures or something?
Of course.
Thank you. Okay, awesome. What's up? TS Temper, Smack the Cat. What's up, guys? Okay, cool. Let's start off office hours because we got a lot of fucking people to go through today. All right. Welcome, everyone, to Office Hours. My name is Dr. Gold. This is Actual Education, a stream that helps you out with your math homework, science homework, whatever homework you need. You got tests coming up. I got you, bro. I got you.
Nice.
Awesome. Okay, cool. So, let's see. Quandle Dingle, you posted a screenshot? Since you've never asked a
Yes.
question before, I'll go through yours first. All right, let's see. Oh, I need to stream on the Discord too. My bad. My bees. Let me do that. One sec. Screen, cool. All right, so you should be able to see in the Discord a screen of sorts. And then, here we go. Copy image. Oh, we're going to go over formal charge probably, right?
Yeah, probably.
Cool. Perf, dude. All right, nice. All right, coming up.
Yeah, I'm on mute real quick.
What's up, Drip Ice? How you doing, dude? Drip Ice, you got like 9 eliminations in the Fortnite games on Monday. That was pretty sick, dude.
That's dope.
All right, I'm gonna chill in the air horns. I'm a little air horned out today. All right, let's see. Where are you at? Come here. This is interesting that they put it in like this line notation here, Quandle, because it's like that's like OChem. Is this intro chem or organic chemistry?
Oh, my bad. I looked for like a question online. So like, do you typically do resonance structures? Like, do they give you like a specific element and you can write it?
Yeah. So here, let's look up I mean, this does work as well. Determine if there are resonance structures. Here, let me just find one for you real quick. All right, so we're gonna go here. I mean, this helps if you have a test or something coming up. Your teacher should be giving you like a test review or something, right?
Yeah.
Right, and that should have questions involving like stuff that you need to do. This is the classic one. NO3 minus, yeah. Well, yeah, that's an easy one. I want resonance structures with formal charge. What is the classic one we do? Yeah, this one's easy. Uh-huh. The fuck? Excuse me? Why is that -1? Oh, no. I want the one where I have to, like, compare the two. Okay. Actually, this is a good one. Yeah, okay. Is this SCN or CNS? What do they call this bitch? CNS. Here. Classic. Oh, CNS minus. Oh, okay, cool. All right, here's an example of a question they could do for you. Okay, so yeah, it's a good question of like what is resonance, right? So resonance, first, you need to know how to like draw Lewis structures. You know how to draw Lewis structures, Quandle?
Yeah.
Okay, good.
Wait,
all right.
is Lewis structures and Lewis dot structures, are they
Same
the same
thing.
thing?
Same shit.
All right, yeah.
Okay. So, all right. So I have CNS minus. All right, CNS minus. Okay. What I'm going to do is I'm going to calculate the number of valence electrons in each thing. Right. So I believe carbon has 6. Is it 4? I gotta get
Yeah,
periodic.
Oh wait, hold up. My
Yeah,
bad.
let me get a periodic table. I need the periodic table for this. Okay.
Yeah, it's 4.
Carbon is 1, 2, yeah, 4, 5, 6. That's what it is. Okay, so 4, 5, 6. All right. So what you do is you add up the number of electrons you have here, right, which is 15. Okay, and then you take what the overall charge is, which is a minus. Bob says Lewis structures. Oh no, yeah. So this is a minus. So you get an extra electron. So now there's 16 electrons. Do you see that? Right.
Yeah, you divide, right?
Good. Divide by 2. You get, I say, like 8 bars. Okay. So what I'm going to do is I'm going to put these things in order, right? I'm going to have C. And let's pretend they didn't even like show you this. Sometimes they'll just say you have this and like find the structure. So right, you could have C and S, or you could have N, C, S, and all sorts of different things.
Wait, so
Yep.
when I'm drawing the resonance structure, how do I know which element goes first to draw
ahead.
the Lewis structure?
Okay. There's a bunch of different combinations here, right? So, in general, we probably want carbon to be in the center. I'm just going to say. Wait, CNS or NCS? Well, these are the same. This is the same fucking shit. Okay. Carbon wants to make 4 bonds, right? In reality, you could actually you could also put the nitrogen here if you wanted to. And there's actually a ton of different structures, but let's just consider these two as like resonance structures, okay? So you have 8 bars, right? So one way, so what I'm going to do is I'm going to connect everything first, right? And then I'm going to see like what I would need to do in order to have everything be happy and have 4 bars connected to it, right? So I would want nitrogen to be like this, sulfur to be like this, and I'd want carbon to be like this, right?
Yeah, I got you.
Now, the problem here is this uses 3, 4, 5, 6, 7, 8, 9, 10 bars. I only have 8, right? So I got to consolidate 2. So what I have to do is I either have to like take this one, make it a double bond, and then maybe take this one, make it a double bond, and then that would give me this, right? Now nitrogen is happy, right? It has 4. Carbon's happy, it has 4. Sulfur's happy, it has 4, right?
Yeah.
The other way I could have done this, right? So this is one of the structures that could have happened. The other way I could have done is I could have taken this bond right here, and I could have this one right here, right? And I could make this one a triple bond, and then make this one a single bond, right? 4, 4, 4. This is good. And then additionally, there is another one actually, right? Because I could do the opposite, right? I could take this one over here, make this one the triple bond, right, and then do something like that, right? That would also be okay. Wait, no, that wouldn't be okay. Give me a second. Sorry. This is what I want. There we go. 4, 4, 4. Right? You see how I can either have 2 double bonds between the N and the S's, I can have a triple and a single, or I can have a single and a triple, right?
Yeah.
Okay. Now, the thing you want to determine is which one of these is the most likely, right? So in drawing your resonance, right, you would do this, and then you would put arrow, 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 right? Because technically these are all correct, right? That's what resonance means. It could be any of those. But there's one that it's going to be most likely, and that has to do with which one is the most stable, and that has to do with formal charges, okay? The equation for formal charges is, I believe it's valence electrons minus, what is it? Minus
Bonded.
bonds, minus
and
bonds, minus
no bonded, non-bonded.
unpaired electrons, right? That's what it is. Is one of these divided by 2? I always forget. One of these is divided by 2. Give me a second. Formal chart. I see you. Who's being creepy to me on the fucking voice chat? You chill. Total number of electrons in shared bonds. Right. Okay. So that B over 2, that's just the number of bonds. And then N is the N is the number of non-bonding valence electrons. Oh, that's times 2 then. Oh, ew, gross. Really? I thought it was it was a nicer equation. One sec. I've done this before so many times. What's up, dude? I always gotta remember this. Let me see, for instance, here. Okay. Yes, carbon has 4, 2 non-bonding, and then 6 minus that. Okay, and then... Oh, okay. I guess that works. Valence electrons minus lone pair electrons, right? Oh, but we can... Yeah, okay. And then minus the number of bonding electrons minus 2, divided by 2, which is the number of bonds. Oh, okay. All right. Yeah, okay. This is what it is. Does this make sense so far? This is the equation. I'll show you how it works in a real sense, right? Okay. So nitrogen. So here, let me just get these so I know this. So this is 5, this is 4, this is 6, right? Let's go and calculate the formal charge on everything. All right. Nitrogen is 5 valence electrons minus 2 bonds, right? So that's 5 minus 2 is 3. So this is 5 minus 2. And then minus the unpaired electrons, right? There's 4 unpaired electrons, right? So this is going to be an overall... Good? What's up?
Hold up. Like, why do you have to subtract the valence electrons from nitrogen instead of, like, shouldn't you do, like, the total added?
No. So it's valence electrons, right? That's 5. Nitrogen has 5 valence electrons, right? Minus the number of bonds, which in this case, right, this one has 2 bonds, right? It has the double bond to the carbon. That's minus 2. And then minus unpaired electrons. There's 2 unpaired electrons here, 2 unpaired electrons here, so there's a total of 4. Do we see that?
No, we're blind.
I know. You guys, this is chemistry. This is hard.
Don't even remind me of chemistry. I got chemistry tomorrow and I suck at it.
Well, then let me help you, dog. Quandle, you still alive, dog? Did we lose
Yeah,
Quandle?
I got you.
Okay. Does that make sense?
Yeah, kind of. A little bit.
Well, what doesn't make sense? Like, let me help you out, dude. They usually call this, like B over 2.
No,
Because this is...
I understand the formal charge equation, but what's it called? Non-bonded is like, for example, in like the second resonance structure.
Yeah.
For what's the element? Sulfur.
For nitrogen.
Sulfur?
Oh, for sulfur here?
Yeah. The non-bonded would be like the bars around it, right? Since they're not touching the
Good.
yeah. So that's non-bonded, right?
Yes, but
So
each bar has 2 electrons in it, right? This has 2 electrons in it, technically. So here, let's calculate the formal charge on this one. Sulfur, 6. How many bonds are attached to the sulfur? How many bonds?
It has 3, right?
No, it's got 1. It's only got 1 bond to the carbon, right?
Hmm.
Do you see that?
Yeah, I see that.
Okay, how many unpaired electrons does sulfur have?
3. I mean, 6.
6.
9, my bad.
No, 6. It's 2, 4, 6. Again, this is not an unpaired electron. This is a bond, right?
Bond. What about the to the left of what's it called? To the left of the carbon.
Here?
When it's those are bonded with the nitrogen.
Good. Yeah, so here's what we're going to do. We have to calculate the formal charge on each element, okay? Is what we have to do. So for this one, it's 6 minus 1 minus 6, right? So this has a formal charge of minus 1. Let me go through and do all these. Well, you're going to go through and do all of them, but okay. Let's see, for instance, here, let me color code these two. Let me do these ones as green. So this one, right? Nitrogen had 5 valence electrons, right?
Yeah.
Minus the 5 valence electrons minus how many bonds does it have?
Minus what? 5 valence electrons?
Minus how many bonds?
3, right?
No. How many bonds are on the nitrogen?
Oh, my bad. 2 non-bonded and 2 bonded.
Okay. So I'm going to do 5 minus what?
2.
Good. Minus what?
Minus 3. The
No.
carbon? No. Minus
No,
the
no.
bonded, right?
No. Yeah, just look at the nitrogen. How many unpaired electrons are on the nitrogen?
2. I mean, my bad, 4.
4. You get it. Just take your time, dude. You got it. So 5 minus 2 minus 4, right? That's also going to be -1. Good. All right. Let's do the carbon. So just look at the carbon. Just look at the carbon here, okay? Valence on carbon is 4, right? That's 4.
Yeah.
How many bonds are there?
There's 2 bonds.
There's 2
4
here,
bonds.
2 here. There's 4. How many unpaired electrons are there?
0.
Good. So the formal charge here is 0, okay? All right. So that's -0. All right. Now let's look just at the sulfur, okay? What's the valence on sulfur?
Sulfur has hold on. Sulfur has 6 valence electrons.
Go ahead. 6 valence
So
electrons. How many bonds?
2 bonds, which are 4 electrons.
Good. And then yes, -4 unpaired electrons because you got 2 from here and 2 from here, right?
Oh, so when I'm bonds, like I don't simplify them into electrons. I just
No.
do like how many.
Yeah. The equation they give you, Quandle, is they say it's B/2, but like that to me is fucking confusing, dude. If I'm like B/2, that would be bonded electrons divided by 2. You can also just say bonded. You can just say bonds, and now you don't have to divide by 2, right?
Yeah.
Okay, good. So this one ends up 6 minus 2 minus 4, right? So that's 0. Okay. Good. So that's how we calculate formal charge, right? For this one, all right? I'm just going to go through and do these real quick. But you should practice this yourself. Do you understand how to calculate formal charge now?
Yeah.
Okay, good.
It's
Good. So this is 5 minus 3, which is 2. 2 minus 2, this is 0. This is 4 minus 4, which is 0 minus 0. Cool. So we got 0, 0, minus 1 again. That's nice. Fuck. God damn it. Move. All right, cool. All right, then let's go here. Nitrogen is 5. 5 minus 1 is 4. 4 minus 6. This is -2, right? So this looks bad. Carbon here, this is 4 minus 4. That's 0. Sulfur here is 6 minus 3, which is 3. 3 minus 2 is +1. Okay. So looking at these, right? What you want in general, and this is kind of honestly like a crapshoot. You have to kind of like look at it and like it's not always correct, but in general, you want everything to have a formal charge of 0, or at least the lowest formal charge it can, right? So it turns out that these two would be the most likely, whereas this one would not be very likely, right? Because this one has a -2 and a +1. Like that's ugly, right? We do not like that, okay? So when drawing your resonance structures, it would probably just be these two, honestly. You just wouldn't even draw this one. This one is technically correct from like a steric, from like an electron point of view, but from the formal charger point of view, it should be a lot less likely than the first two.
good.
Good. Technically, if they ask you which one is more likely, I think it's the one that has the minus charge on the more electronegative element. I think if they really want to get, like, it depends how picky your teacher is. And do you remember electronegativity?
You mean electron configuration?
No, electron negativity is a periodic trend. Okay, so you probably learned this in the beginning of.
No, I didn't get to learn it. I still need help with it.
Really?
All
right. Well, here you go. Well, that's another thing for another lesson. This is why you should show up to my streams, because I can just teach you all this. Like, I literally taught a student all this today. But that was during one of my. I have like I teach privately to pay my rent. But here, why the fuck is this not pasting? You dumb bitch. Come on. 1 sec. Copy. But I also I teach here 3 times a week for free. So use it. Okay. These are periodic trends. You need to know these. You should memorize these. I can explain how they work at another time, or if I get through everyone today, I'll come back to you and I can go through this again.
All right.
But in general, electronegativity is peak here and it's weak over here. Okay, so in terms of like looking at our elements, remember that I think nitrogen's here, carbon's here, and sulfur's here. This is like the most top right, okay? So that's the most electronegative. So you want the negative charge to be on the most electronegative thing. So I believe this one would be the dominant Lewis structure. And that's actually interesting. This person maybe chose the wrong answer. I'm curious actually now. What is this? Let me see. Someone solved this before. I want to see. Are they going to do something where, oh, you got to... Oh, dude, I hate this shit, dude. Like, fucking pay for the answers. This is so dumb. Here, 1 sec. I have Chegg on my phone. I want to see what this is. CNS minus dominant Lewis structure. No, not on Numerade. Where is... I want the Chegg answer. Good. Here we go. They like the yeah, okay. Let me see. Okay, they agree with my answers. They say it's either one of those. As to which one is exactly the more possible. It's kind of up for debate. Yeah, it's both of them. It's both of them is what it is. Okay.
Okay.
Cool. All right, cool. All right. Congrats, dude. Does that make sense? Does that make more sense to you?
Yeah.
Yeah? Nice, dude. Cool. You get a bond coin for asking that question. Do you know how bond coins work?
No.
Okay. So basically, if you ask questions in this Discord and you ask enough of them, you earn points, and then once you have 10 points, I buy you a gift card. So it's kind of like an extra incentive for you to like learn. Cool. All right. Here, and here's another thing I can do for you here, Quandle. I'm gonna download this real quick, and then I'm gonna post it here in the Discord, and I'll tag you so that you can look at this sheet if you need to later. Cool.
Yeah, I got it.
Awesome. Okay, but yeah, if you have any other questions with stuff, just stick around, and I'll probably get to you later. Cool. Otherwise, I stream again on Fridays. All right.
Oh, bro.
Okay,
That's
cool.
not awesome. You're awesome.
You're awesome. Thank you. Okay, let's see what else we got. We got lots of questions. Okay.
Yo, Demented is on another level, bro.
Is he? What is Demented doing, dude?
No, you don't even want to know. Holy shit.
Okay.
Bro, I'm losing up everybody in the Discord server, bro.
All right.
Yo, what the hell?
Okay, here's my question. Who has a test coming up tomorrow that they need questions with? I'm gonna do it in order of urgency. who
I have a test tomorrow.
has a
I got
test
an
tomorrow?
exam coming up next week.
I know Demented has an exam. What else, JX? You have a test,
Yeah, but I don't need help with it.
but you don't need help.
I
Okay.
know.
Okay. Anybody else? Does anyone else? Teacup has a test, but yeah, Teacup, your test isn't on this stuff. Bob has a test. Bob's test is this week. Okay, cool. Bob, we're gonna do yours next. And then I'll go through all the list of stuff. I want to do like order of like. I appreciate all you guys asking questions, like learning and whatnot. But let me try to prioritize who's got tests coming up.
Yes, sir. Yes, sir.
All right. So I'm gonna do Bob first, then I'll do Demented, and then I'll go through the order of who basically submitted in time. Okay, Bob, what's up? You here?
Yeah, I'm here.
Nice. Okay, here. Let's do number 6 here. Okay, here's a graph, right? The function is this, okay? Estimate g of x. Oh, wow, the graph is the integral? Ha! Half Alpha says, I have an advanced geometry test. I'm Firefox, blah, blah, blah. Cool, cool. Half Alpha. If you have a question about your geometry test, like, can you post a screenshot in the Discord? I'll go through your question. Okay. This ends up dealing with what's called the fundamental theorem of calculus, Bob. Okay. Which I'm gonna show you real quick. If I have a function, g of x, which is equal to the integral of 0 to x, f of t dt. Okay. Do you know what the derivative of g of x is?
It'd be the.
Do you know what the
Would be the
derivative of
integral?
derivative of an integral is? It's kind of a weird thing, right?
Oh yeah. No, I don't know how to do it.
You don't know what it is. Okay, that's fine. That's totally fine. Okay. So, if you're taking the derivative of something with respect to x, okay, right? And the thing you're taking the derivative with, that variable also shows up in the top of the integral, okay? And then these are different. You want these to be like f of t dt. You want these to be different variables, okay? This is also equal to... So, the cool thing is, you know how, like, the derivative is called, like... Sorry, you know how the integral is called the antiderivative?
Yeah.
Right? So when like a derivative and an integral like meet each other, they blow each other up. They cancel each other out. It's like when matter and antimatter like meet, or I don't know, like
Matter and antimatter.
matter and antimatter, or two opposites, right? Just things just like.
But they're always meeting up. Like 99% of space is dark matter, and then
Dark
the rest
matter,
is
which isn't antimatter.
matter.
Yeah, that's a good one. That's a good point. Yeah. So what happens here is
What is
you
the
end.
difference?
Oh yeah, what is the difference?
Well, I'll get into that. That's another thing. So, but Bob, if you're taking the derivative of the integral here, and this variable also shows up here, this is also equal to just plugging this in to the function. So this is the same thing as just f of x. So g prime of x is the same thing as just taking whatever the function is here and plugging in x for like t. Do you see that? Yeah. It's kind of a weird thing, but I could prove why this is, but that takes time. I can prove it to you later if you want, or I'll make a video about it. Okay. All right. Cool. So here's a graph of g of x. This is weird because this is the graph of an integral. What this is saying is that as I increase x, right, as I increase where I'm integrating to, like, for instance, this could look like something like this is, for instance, f of t, and then this is like x. It's saying that as I integrate further and further down, I'm getting different values for what that integral is, okay? So, they're asking here, what is g of x for x equals 0? This is the graph of g of x. Y here in this case is g of x. So how would I figure out what g of 0 is?
Wait, but it says the graph is f.
Oh, you are so right. I'm fucking retarded, dude. Yes, thank you, dude. Sorry. I thought this was a different type of question, but yes. Okay, that's f. Okay, cool. My bezels. Oh, okay, they do it. Okay, well, first of all, they shouldn't just call this y, dude. That's fucking wrong. Well, God damn it. They shouldn't call this y, dude. They should call this f, but okay, whatever. All right, this is f. Okay, good. All right. Let's look. G of 0, right, is the integral from 0 to 0 of f of t dt, right? If this is the graph of f, okay, first of all, it doesn't even matter what f is. If you integrate from your starting point into your end point and they're the same, what is that integral?
0.
0. Good. All right, so that one's 0. Okay, let's pick another number. Let's pick, I don't know, let's pick 5, for instance. I'm just going to jump ahead here. Okay. What is g of 5? How would I do g of 5?
Would it be 0 also?
Let's see. So that's the integral from 0 to 5 of f of
0
t
to 5.
dt, right? Okay. So that is integrating this from 0 to 5, okay? So you see how I'm going to have positive area here, right? And negative area here?
Yeah.
Okay. So first of all, this positive area is going to cancel with this negative area, so we don't need to do... This is why, for instance, what would g of 2 be?
So g of 2 would be 0.
Good. Because you're integrating up to 2. So you're integrating positive, negative, this goes away. Cool. That's why g of 2 is equal to 0.
Okay.
Right? as we go to g of 4, right? G of 4 would also be 0, right? Because you got negative and positive, right? This is how you can kind of just look at it and see it, right? That's 0. Okay. So then g of 5 would just be this stuff that's left, right? Which is just going to be 1.5. Right? Because you got one block and then half a block. Cool?
Cool.
All right. Sick. Where does G have a minimum value? Where does it have a maximum value? Where does it have a minimum value? Explain your reasoning. Okay, so you actually don't need to know this. This was, I was teaching you this in case this was G of X. You would need to do this. But this is also, have you ever seen this before, actually? Probably not, right? Yeah. You're going to see this soon. This is something to know, but we'll get to it. Okay, so where does G have a maximum value? So they're saying, where do I integrate to have the biggest number, right?
7.
What would that
right?
be?
'Cause-
Yeah, good. Because, right, you get like nothing out of this, right? You get some negative, you get some positive, but then going all the way to 7, right, you get all of this positive, which gives you your max. Okay. Where's my minimum value?
At 3.
Good. Because, again, this will cancel out to 0, and then this will be the only amount that'll get you negative, right? So you're like positive area, 0 area, negative area, back to 0, and then up. Yeah. Oh, then they want to sketch a rough graph of that. Okay.
I could do that.
Yeah, you know how to do that. Okay, cool. Awesome. Let's get the next part of your question here. This one real quick. Dude, what's up with my sound drivers? Excuse me? Oh, one sec. This is wrong. This is wrong. This needs to go to... Oh, shit. Which speaker does this go to? Voice meter... I believe it's that one. Okay. All right. Oh, there you go. Now it fixed it. Oh, cool. Thanks for the follow, Half Alpha. Oh, Half Alpha, are you in our Discord? Do you know what our Discord is? Should check it out. It's exclamation point. Okay, good. Thanks. All right. All right. Here's the area of the region labeled B is 3 times the area of region labeled A. Find an expression for B in terms of A. Okay. So we want to write this as like an integral, right?
Yeah.
So how would I write the area of A? What would the area of A be as like an integral?
So from 0 to A.
Go ahead.
Of E of X.
Dx, right?
Mm-hmm.
Uh-huh. And the area, okay, and then this would be 0 to B e to the x dx, right? Okay.
Yeah.
The area here in label B is 3 times out of A, right? So this is equal to this times 3, right?
Uh-huh. Oh,
Okay.
so is that all I do?
Yeah, good. And then integral of e to the x is what?
E to the X.
Good. So this is just e to the A minus e to the 0, right? Times 3 is equal to e to the B minus e to the 0, right? Yep, good. So then that's 3 e to the A minus 1 equals e to the B minus 1. This goes away. This goes away. What do they want you to know? Find an expression for B in terms of A. Oh, that's kind of cool. You can ln both sides. So, well, okay. Yeah, okay, cool. This is ln of 3 e to the A equals ln of e to the B. This you can split out. Do you remember your log rules? How do you split this?
Is it ln3
Good.
plus ln plus?
Plus
ln.
ln of e to the A, but ln of e to the A is the same thing as a ln of e, which is just A. Because the ln of e is just equal to 1.
Okay.
Yeah. Does that make sense? Sorry, I sometimes go a little fast.
Wait, can you repeat that last part?
Yes, yeah, let me do it. Okay. All right, cool. This is ln of e to the A, right? Remember our log rules. Exponents I can pull down, right?
Uh-huh.
What's the ln of e?
Oh, 1.
1. Good. So that's why this is just ln of 3 plus A is equal to same thing here. Pull down the B. ln of e is 1. This is just B, right? So B equals A plus ln of 3, and you're donezies.
Okay. Thank you.
Very welcome, dude. Nice.
I actually have a question.
What's up, Teacup?
So, I do actually have a test-related question, but the question is, should I actually send it?
Do you already know how to do it? You get like hundreds in all your class. I know you're fucking smart, Teacup.
Listen, just because I have a 99.39 in algebra.
Yeah. Yeah, you're fine in algebra, dude. No, don't worry. I like you going over more complicated things. Don't worry. We'll go through your
Damn,
question.
Bob has 62 bond coins. What the hell?
Okay. Here we go. All right. Firefox says he has a test tomorrow. Let me do his real quick, and then Demented, I got you, and then I'll get everyone else. Okay, cool. All right. What's up? Is Firefox in the chat, or is he in the Twitch? Where's he in? Or Half Alpha, right? It's his name, right? There we go. Oh, what's the scale factor? Oh, this isn't too bad, dude. Not bad at all. Okay. Okay. Half Alpha. Scale factor. Well, someone else can probably do this, right? Scale factor is always going to be, let's say we're going from triangle A to triangle B, okay? The scale factor is going to be the length of one of these B sides divided by the length of one of the A sides. So this is not too tricky. That's pretty easy. You have to make sure they're the same corresponding side, though. Oh, Bob, do you want a screenshot? Yeah, let me get your screenshots. Sorry, my bad. My bad. Bob 5. Let's save this one. Bob 6. Okay, I think I got it. All right. So what is it? What is it though? What is it? What would the scale factor be here? 1/2. Close, but no. So maybe you don't got it. We're going from this triangle to this triangle, right? So that's from the left triangle to the right triangle, right? What is that going to be? 1/2 would mean it's getting smaller, right? What happened to my Dragon King, dude? Where did we go? Oh, 2 for 1 because you swapped triangles. Yes. Yes, good. Also, anyone else in the crowd? Does anyone know, like, what this means? Does anyone know why there's 1 line here, 1 line here? There's 2 lines here, there's 2 lines here. There's 3 lines here, there's 3 lines here. Does anyone understand that? Same angles. Yes, Bob. Yeah. If we say this is this, that means that this angle is equal to this angle. Like, it's the same amount of angle. This one corresponds to this one corresponds to this one. When we do scale factors, you have to do the same corresponding side. So in this case, I do the longest side of this triangle divided by the longest side of this triangle. So that's 20 over 10, which, yes, gets you 2. Good job. Dragon King. Okay, good. Okay, cool. All right. Also, if things are like the same length, this is actually kind of a cool thing. If we had like stuff like this, and this was the same length as that, you would put a single line. If this was the same length as this, double line, and then you can go so forth and so forth. All right, Demented, are you here or are you AFK? He said AFK in the chat. Don't know what that means. Here.
I invited somebody.
Nice, dude. I'll get through all the... There's so many invites I need to go through. I'll go through everything today. Today's been such a mess of meetings getting canceled and whatnot. That's why, like, I thought office hours started an hour earlier because they, like, last minute canceled one of my board meetings. And I was like, what? When you back. Okay. Let's see who else got the questions. Grim's got questions. I don't see Grim in the VC, though. Shaq here. Shaq around. You got a question. I like that. Shaq actually had a good question about YouTube stuff that I wanted to do. Okay. Next up would be Ethan. Ethan, what's up? You in the chat, Ethan? Where you at? Where's the boy, Ethan?
Grounded.
Everyone's submitting questions, but you can't be AFK when I go over it.
I'm not AFK, but Glim got grounded.
You got grounded?
Yeah, Glim got grounded.
Okay.
Wait a second.
Okay.
I feel like I know this guy.
Here, Teacup. We're gonna do your question because you're the next one up.
Oh, okay. Wow, what happened to everyone else?
I don't know. People posted questions and then they like, I don't know, go eat snacks or something. All right, this is cool. This is called U substitution, I believe, is what this is.
We haven't done that. We've done choice substitution.
Actually, no. Sorry. This is
So
fuck. This is integration by parts.
well,
Ethan,
we
I'll
have
do yours
done
next.
that.
Just you gotta be here.
Oh, he's back now.
It's okay. All right. Integration by parts. I'm gonna do this real quick for you. Okay. Integral of u dv is equal to uv minus the integral of v du. You're gonna have no fucking clue what this is. Bob, you should actually pay attention to this. This is actually a good technique. I'm just gonna go through it and then take what you can from it, and then we'll see how much you guys learn from it. Okay, first thing I want to do is this is a constant. Anytime I just have numbers multiplying through integrals, you can just pull them out. So I'm gonna ignore this shit and just say we're just looking at the integral of t squared ln of t to the third dt. And then what I'm going to do also, I assume this. Well, this is interesting. Is this cubed hitting the t or is it hitting the ln?
It's hitting the t.
Well, no, this is
just
tricky.
Outside of the.
Well, no, because really, if it was hitting the t, it should be like this.
Math make my brain hurt.
Where'd you get this question from?
Wolfram Alpha.
Can you send me the link to it?
Oh yeah, I got you.
Because I think that's a typo, and that's going to very much change how I approach this question. Is it like messing up my speakers, dude? No, that's okay. Oh, did you post in office hours? Okay, cool.
Yeah.
Oh, problem. This is what you use? Use a problem generator? That's kind of cool, actually.
It's got all these different subjects too.
That's pretty cool. No, that's dope. Okay, I'm gonna try and do it this way. I think it'll work. I'm gonna say that the cubed is hitting the t is what I'm gonna say. All right. Okay.
Okay.
So he gets unlimited questions. Yeah. Well, I mean, they're all kind of related. All right. Okay. So u in this case is going to be equal to, I want to do something that I can easily take the derivative of, which I think I can take the derivative of this pretty easily. But eventually what I want to do is I want to reduce this ln of t down to something nice.
Hello.
Yo, what's up, Omega? Good to see you, dude. You know what I'm gonna do? Because this is gonna get very long if it's t cubed. I'm just gonna say it's t. If I do t cubed, this is gonna get really long. I'm gonna say that u is equal to ln of t, and because it is a randomly generated question, which means they could generate something that could take me a while to do. And I'm gonna say that dv is equal to t squared. Okay. So that means, so if u is ln of t, do you know what du is? Do you know what the derivative of ln of t is?
Wait, so if du, so it would be p squared. Wait, no, that's dv. Wait.
No, I know. You probably actually don't know this one. It's a special case.
Probably don't.
Du, the derivative of ln of t is 1 over t dt. Okay?
What?
I know. Yeah, it's a special one. You just have to know that one.
I have a question after this.
Post a screenshot. If it's a math question, post a screenshot in the screenshots one.
It's not a math question, it's a science.
Oh, general question, you can always just ask me, yeah. But let me get through this. Teacup, what's the integral of t squared?
T squared or b squared?
T squared. I don't go t squared.
Integral is just t.
How do we integrate? Right? What do we do to the power?
Do we raise it and then multiply or divide, or do
raise and divide. So this is
or
t to the third over 3.
And multiply.
No. Drop and multiply is derivatives. Okay.
Oh.
Which would have been for here, but this is ln. Okay. All right. Now that you've built this out, okay, now you can evaluate these things. So uv would be this thing times this thing. So that's just going to be 1/3. Oh, this is a gross color. All right, there we go. This is 1/3 ln of t times t cubed, right? That's the UV, minus another integral we got to do, which is v, which is t to the third over 3 du, which is 1 over t dt. See how this is a much... I don't know how to integrate this, like, off the bat, because, like, t squared and ln of t, like, these are all, like, really gross things. But if I just have a simple polynomial, like, for instance, this was easy for you to integrate. The integral of t squared is you just do the power rule, and you just raise the power and divide by the number.
Yeah.
What this did, this integration by parts, is it took this messy fucking clusterfuck of an integral and turned it into a simple thing with hopefully a simple integral, which this is going to be in a simple integral, okay? Because this is minus the integral of 1/3. What is t cubed over t?
T cubed over t?
Yeah.
I have no idea.
Exponent rules. What is t cubed over t to the first? You guys should know this.
I thought you couldn't multiply.
No. We're just dividing. We're dividing. What happens? Okay, you know this, teacup dog. If I have x to the a times x to the b, what do I do with the exponents?
Wouldn't it subtract?
They add. Add.
Oh, add?
Yep.
Oh.
If this
the
would be...
exponents add together?
That would be x to the a plus b, okay? All right?
Oh, so would it
If
be
I have x to the a
equal?
divided by the x to the b, okay?
Subtract.
Good. These subtract. This is x a minus b. Good. So in this case,
Wait.
good. Very smart. Okay. T squared. Do you see how this is an easy integral now? Because, like, what's the integral of
Yeah.
t squared? You literally just did it, right?
Very complicated.
Very
Yeah.
complicated. What is it?
Wasn't it?
We literally just did it. What do you do with integrals?
Wait.
You got it, dude. I know you do.
We raise the power and then divide.
Right, yeah, good. So raise the power. So this is going to be minus 1 over 3, t to the third, divide by the power 1 over 3. So 1 over 3 and 1 over 3, this is technically minus 1/9 t cubed, right? This shit comes down to. This was 1/3 t cubed ln of t. And then the final thing is we got to remember that we pulled this 3/8 out, okay? So there's technically a 3/8 at the end as well.
Oh, so we still have a 3/8 here. So now we just multiply it all by 3/8.
Yeah, there you go. You're done. Nice. Nice. Good job.
I'm totally super smart.
That's cool, dude. You know, that was like a little workout. I had to like do a flex. Like I haven't done integration by parts in a while because like we haven't gotten to that part in calculus with the kids I teach like privately. So like it's good for me to like I appreciate the workout. It's like I had to remember how that works.
Well,
Okay.
I'm gonna be totally honest. I didn't even select that. I went to calculus and select summary, and I just copied that.
Calculus and just selected summary. Yeah.
Yeah, it's kind of a cool website though.
Oh, okay. Yeah.
I invited
That's all the
another
Wolfram
person.
stuff. All right. What's up? Omega? You had a quick question, and then Demented. I'm gonna go through yours.
So,
Well,
You
Yeah.
just skipped Ethan.
Well, no. Omega has a non-math science related question.
Oh.
What's
so
up?
This one's kind of like a two-parter. So,
Oh.
you know how like VR, why does VR headsets, how do they work?
Oh,
Like-
they have
Sensors and cameras.
Actually, it depends on the VR headset. However, so what they do is they have an OS built into it. Most of them use the Snapdragon, and what it is they have these tiny little screens.
Mm-hmm.
They're so close to your eye that they look realistic,
Yeah.
and they have a high resolution at most times, so you can't really tell. And then they also the visor thing, as well as helping you to maintain the grip on it. It blocks out the light.
Good.
So it actually does that. And then the OS is up to them. Controllers, it also depends. For the Quest 2, for example, they have cameras on the Quest, and then it uses infrared lighting for the controllers to track
Yeah.
the own.
Yeah, that's pretty cool. Also, they use the cameras to see you around your surroundings, right?
Yeah,
So you
sometimes.
you don't bump into shit.
That's like
And-
for like 3D. I mean, it depends on what you're using.
Right.
So, like you're using like one of the new Oculus shit, you don't
Mhm.
need that because they have built-in cameras.
Right.
But if it's some of the older ones, you need like an entire room filled with cameras.
I
and
know.
sensors, which is
Yeah.
So
bad.
The Vive, the old Vive needed
You
that.
have to link it to your Quest, and you have to have like
Sensors are
face
what,
sensors.
$200 each, and
Yeah,
they're
they're
fucking.
$200 each.
Yeah, they're
so
fucking
the entire
expensive.
kit's like 15 grand, no, 1500.
Then you have to plug it to the computer.
Correct.
sometimes.
Yeah, you need to tether it.
Wires so you can like trip on your own fucking wires. It's a pain in the ass. Just get an Oculus
However,
Quest.
now,
Yeah,
I
the
don't know if
Oculus
you
Quest
guys
2 is
knew
cool.
this.
Hello?
I don't know if you guys knew this. There's cloud
This
game.
is an actual
What's up?
this is an actual science question.
Okay.
We just went try-hard mode on
Why
VR
are there
stuff.
so many different types of why are there so many different subtypes of rocks and
Subtypes of rocks. Oh, that's a good question. Actually, I know nothing about rocks.
Erosion.
just learning about like sedimentary and like we were just learning
So
about
let me
sedimentary
explain this the best that I can.
All right, Teacup. Teacup will explain it. Teacup, you explain what the
Best
different
that I
types of
can,
rocks.
To my greatest knowledge. So over the years, erosion has done a bunch of stuff, and it comes from all. So erosion takes the different shapes in rocks, and then there's all the wind and stuff being compounded into it.
Yeah.
That makes all the different types of rocks. But the rocks themselves come from like molten lava getting hardened and stuff. That's actually how Hawaii was made. I'm pretty sure.
Yeah, it's a volcano. Yep.
And so all of that, and then there's a
I
bunch
have
of
a-
other stuff going on.
That's
I
cool.
just forgot. I remember.
That's pretty dope.
Another question. I asked one question and then it just comes in after another. This is the final question.
Oh, final question before I work with Demented. Yeah.
got this.
What is
Let's
it?
see. Can I
so-
solo this?
How do volcanoes form?
Oh, so volcanoes are.
Hey, let's get it. Let's
You
get it.
actually know. Go. You can answer this.
No, you get it. No, Teacup, you answer it, dude. I like that. I like when the students answer. You go for it.
Okay, so volcanoes. Let's see if I can remember this.
Mhm.
So they have a bunch of the little lava stuff. I'm pretty sure it's like heated water, and it gets to the point where it starts forming the all underwater. I don't actually know.
There are faults. There are faults.
I got you.
Yeah, Demented.
They're
Demented
fault
say it.
lines.
Demented say it.
Fault lines.
I got you. So like the Earth's core, you know how it's like basically as hot as the fucking surface of the sun?
It is. Yeah, it's fucking hot.
Yeah. So around that, there are some rocks that can take up that heat, and there are some rocks that cannot. And some of those, they fucking melt, and now they become molten lava.
Ooh, yeah,
now
yeah,
they're
yeah.
flowing around there, and because of the fucking air pressure, that air gotta escape. Now, how does
Yeah.
the air escape? It gotta move the particles. But because lava is technically like half a solid and half a liquid, it starts moving up.
It's less
and that's
dense.
it. It's less dense, so it just moves up, and then it slowly makes its way up to the surface.
Yeah, that's cool, dude.
Magic.
Yeah, and then it escapes through the fault cracks, and then that causes oh, someone Googled the actual definition. They put it in the first time chat there. Push up magma. Yeah, magma. Magma is the word for that kind of like that rock that's like kind of liquidy, and also
Yeah,
and it
magma.
erupts as it's magma when it's underneath the earth, I guess, and then when it's outside the surface, they call it lava. Right.
Oh.
And like there are little cracks in the ocean that happen because like the earth is a bunch of like plates, and this is how earthquakes also happen.
Oh yeah, tectonic plates. That's
Yeah.
how
Tectonic plates
happen.
just run
Tectonic
against each
plates.
other and then just.
Yeah.
Yeah, shit like rubs together and like
I know a tiny bit of science, but like I'm just trying to come up with questions.
No, that's a good idea,
And-
dude. I appreciate it. It's
I
good,
think
good
you
question.
should get Dweebon coin.
I'm gonna give him one for that. Yeah.
Did we whoever-
All right. Here, let me do Demented's question. That's awesome, Himeg. I appreciate the questions. All right. Demented. Let's do your physics question real quick. An apple drops from a tree and falls freely towards the ground. Sketch the position, velocity, and acceleration graphs, assuming that downward is positive. Oh, that's cool. What? Downward is positive? Ew. Okay,
I
cool.
know, right? I looked at it, I was
What?
so confused.
Excuse me? Excuse me? Why the fuck
Going
is
down
downward
and it's
positive?
positive?
What? That's some toxic positivity.
That's like
You know,
a relationship.
just like a really. I always toxic positivity is such a funny word. It's like when people are like overly optimistic. They're like, "It's okay, Billy, that like you wrecked your car and got your 4th DUI. You're trying, you know." It's like, no, no,
DUI?
beat Billy's ass,
no,
dude.
fourth.
Yeah, yeah. Why did you make a mistake 4 times? Yeah. Very
Wait,
okay.
Dr. Gold, this is
What's
off
up, dude?
topic, but
Yeah,
have
what's
you
up?
seen the cars that only start when you fucking take the
breathalyzer?
drinking
Yes, yes.
Yeah.
I have some friends that have fucked up, and yeah, they have those in their car. It's pretty interesting. Yeah, don't drink and drive. Don't do it. Don't do
I
it.
fucking love seeing people with them. It's funny as hell.
Yeah, well, it's an indicator of you fucked up. So like, don't do it.
Well, yeah. But what if you just continue
That's a
doing
good
it?
talk. I'm gonna be speeding. They'll never
Yeah.
catch me.
Yeah.
Oh wait, so I actually have a thing on
I've
this.
had friends who have had to like blow for other friends in order to get the car to start because they were too drunk to start the car, and I'm just like, no, dude, like what? It's the whole point of the thing. Like, oh my god, it's so bad, so bad.
Oh, that's priceless.
Priceless,
Hello?
dude. Yes, what's up, Teacup? I can hear you.
So
but-
I actually have a thing on this. So the drunk driving thing,
Yeah.
there's a loophole where if you just chug the entire bottle as you're getting pulled over,
Yeah.
and then you throw your keys into the woods, you can't get a drunk driving fee. You can't get a DUI.
Oh, really? Oh, because
Yeah.
if your keys are not in the ignition? Oh, that's interesting. Yeah.
Because there's no proof that you were driving and you didn't open the bottle in the
What do
car.
you mean there's no proof of you were driving? He pulled you over.
No,
Yeah, they
not
have
that.
they have you on
Yeah,
camera
yeah,
driving the car. They have you on camera driving
Yeah,
the car,
you're
dude.
right.
That's crazy.
Yeah.
No, the driving drunk part goes no because you chugged an entire bottle right as you
Oh, you're
got
still
out of the
drunk. Oh,
car.
you're definitely still drunk. Like
but
alcohol
yeah.
alcohol in your bloodstream takes a very long time to get out. It's like an hour or two. Like drinking water's not going to fix it.
No, you
Let me
weren't
just
drinking water. You just
let me tell you from experience. Chugging water does not make you sober instantly.
No, not that. You just chugged the entire
It doesn't work like
In the
that.
car, no evidence, you know what I mean?
Oh,
Not a thing
okay.
of water, a thing of vodka.
Here's the ultimate solution. Just don't drive drunk. Just don't drive drunk, guys. Just
Nah,
don't do it.
that's
Take the car and you eat it away.
Umar says, do I get a point for giving an answer? You get a point for asking a question. Ask a question. Ask a question. Put it in the stream. All right, Demented, let's do this real quick. All right. Apple falls from a tree and falls freely towards the ground. Sketch the positive velocity and acceleration. So I'm going to call this position versus time. This is going to be velocity versus time. And then this is going to be acceleration versus time, okay? I think the easiest thing to graph is the acceleration, okay? What's the acceleration of something that's, like, falling? Like, we call this, like,
it's
free fall.
constant because there's like if this question doesn't say anything about the like air
Air resistance.
air
Yeah, no,
resistance,
yeah,
so
yeah.
it's gonna
Just
be
assume it's
linear,
zero.
I'm guessing.
Not linear. The acceleration will be
linear,
constant, which I guess is linear.
Constant. I forgot the other word.
No, it's okay. Yeah, so this is what the acceleration is. The acceleration is going to be constant. And even more so, acceleration of gravity technically points down, but this question is saying that down is up. So, all right, whatever.
Which is confusing me. It hurts my
Yes,
head.
so down is positive. Okay, so just make it this way. Acceleration is positive, okay? Now that you have this, okay, you can figure out everything else by just going between what's like the difference between acceleration and a velocity graph. Okay. What's the relationship between acceleration and velocity? Like how are they related? How is acceleration related to velocity?
Acceleration is you get faster over you do kind of get faster over time.
Yeah, okay. So acceleration is the same thing as the change in velocity over the change in time.
Yeah, change in velocity, and then velocity is just speed.
Velocity is speed with a direction. We'll get to that. But here's the relationship.
Oh, yeah.
Acceleration is the change in velocity over the change in time. Velocity is the change in position over the change in time, okay? Now, do you see how we have change in something over change in something? This is the same thing as like dy dx or delta y over delta x. What is delta y over delta x in like math shit with like graphs? Like what is delta y over delta x?
It's not linear. Why do I keep thinking?
Hey, no, you're close. But what is it? Starts with an S.
Slope.
It's the slope. It's the slope. Okay.
It's that
So-
one game that's unlocked that people can play on their school computers.
Slope. Yeah. Okay. So acceleration, right, is the slope of a velocity graph, right? See how this is delta y over delta t, delta y over delta x. Okay. So it's the slope of this graph. Okay. So acceleration is what value for all t? Is it positive, negative, or 0?
It's positive.
Positive. Good. Okay. So that tells me the slope of whatever this graph is also positive. Okay. So if I want to, and more so that the slope is constant, it's constantly positive. So if I wanted to draw a line here on the velocity graph that also has a constant positive slope, what would I draw?
Wait, it'd be like a diagonal line, would it not?
Yes. This would be a line that has constant slope. You see how the slope is the same here, right? Same slope, okay? And the slope is positive, okay? Now, we can readjust this, right? Because this would tell me that the velocity starts as being negative and then goes up to being positive. But if I'm dropping something, was it from a tree? Oh, wow, Isaac Newton.
Yeah.
Okay, cool. If I'm dropping it from a tree, what does the velocity start as, probably?
It starts at 0.
Good. So I'm going to move this graph so it looks like this. I want the velocity to start at 0, and then it's going to go up like that. Okay?
Yeah.
Okay. Let's use what we learned now to figure out what the position graph is. Let's remember that the velocity graph is the slope of the position graph. Okay? Yes, Scary, you can buy a coin. Do it on the stream. So this slope, right? The velocity is the value of the slope of this, okay? What's happening to the value of velocity as time goes to the right? What's happening to it?
It's getting more positive, I guess.
Good. So that means the slope of whatever this is getting more and more positive. Okay?
So it'd be like the same thing as the same graph as the velocity one?
No, because if it was this, right, the slope is positive, but the slope is not changing, right? Do you see how the slope is constant here?
Oh, so it'd be like an actual slope where it goes up and then down?
Not up and down. It's just going to go up. It's just going to look like this, okay? Because do you see here,
alright.
I need the slope. The slope starts at 0, right? Because the velocity, right, which is the slope of this, is 0 here, right? That is no slope, right? Then as time goes on, the velocity gets bigger, which means the slope of this is getting bigger. Do you see how this is getting to be a bigger and bigger slope?
Yeah.
Right, good. That's why the position graph looks like this. This is called concave up, is what it's called. Because it's like curved. Cool? Yeah? All right. So that's how you draw that. This is a big question. They do this all the time in physics. But yeah. Does that make more sense, Demented? Yeah?
Yeah, it makes more sense. Thank you.
Fuck yeah, dude. You're welcome, dude. Nice. Remind me, when's your test coming up, Demented? When's your test? Next week?
Next Wednesday.
Okay, cool. All right, well, make sure you show up Friday and Monday so I can help you out.
Yo, yeah, 100%. You gotta know that I'm showing up. I'm still gonna go
dude.
study after this.
That's dope.
Yes, go through the questions, right? And anything you think is difficult and whatnot, let me help you out with, like save it so that I can go over it during the stream.
Yeah.
Okay, cool. Awesome, dude. All right, let's see. Who else has questions? Grim. Is Grim here? Ethan's here. Ethan, you here again? Or actually, Rottenegg has the first one, right? All right, good to see you.
I'm here.
All right, Ethan is here. Rottenegg technically asked before you. Wait, Rottenegg, are you here, dude? He's muted and deafened, so I can't hear him.
Yeah, he's deafened.
All right. Well, Rottenegg.
Should I get CS:GO?
Sam likes CS:GO. Playmo Lats loves CS:GO. It's a good game. OP Black, we could do your question as well, because you asked a question, but you guys gotta, just speak up. Speak up if you want it. Mark. Who's OU Mark? Who's OU Mark? Is that OP Black? This is a problem when you guys have different Twitch names and Discord names. Oh, it is OP Black. Okay. All right, dude. All right. OP Black. Cool. That's a good one. I like this. It's a good question about functions. We'll go a little bit over time. It's okay. No one fucking likes Warzone anyways.
Oh, darn, man.
But we'll play some Warzone.
In my opinion, I feel like that Warzone just needs to, work on its time to kill. And
yeah, the TTK is way too quick, dude. It's fucking annoying, dude. I hate that. It's just like, oh, I'm dead. I'm just like, what? They need to go back to Warzone 1. Warzone 1 was great. Warzone 2 sucks. Don't like it.
I agree with you there.
Yeah, right?
They
yeah.
kill us.
my bullets hit for darn marshmallows on a Nerf gun. But when their bullets hit me, it's just their bullets are just
yeah, I don't get it.
Anvil or big brawling black dudes.
DMZ's honestly, DMZ's pretty fun. I enjoy DMZ more than there are too many sweats in regular BR. But
do you have you heard of have you heard of
Tarkov?
FaZe Jev?
No.
FaZe Jev made the big brawling black dude named Requise.
Oh, okay, cool. All right, OP Black.
Their bullets hit like Requise.
Nice. OP Black. What's up, OP Black? Oh, nice, Scary. You gotta tell me what your Discord name is. Okay. OP Black. Does this represent a function? This is actually a good question. I went over this earlier with another student. OP Black. OP Black. Does this represent a function? Does it? Let's see. Try watching the Discord stream. There's less of a lag on it. OP Black. I love my little waiting thing. Does anyone know what this music is? Who knows what this music is?
I wish the Twitch wasn't so delayed.
Well, that's why you should watch the Discord. The Discord's not delayed, you know? If I'm doing your question, you really need to be in the Discord. Like, if you're watching, Twitch is awesome. Okay, OP Black's just not answering. Okay, that's kind of rude.
What are we gonna play for recess today?
We're gonna play Warzone. We're gonna play Warzone. Ethan, or Rotten Egg, or Jesus Christ, whose mic is that?
Not mine.
Oh my fucking god, dude. All right, Ethan, you ready? We're gonna do your question.
Yeah.
Okay. What's today? Wednesday? Busy day. 13 viewers in the chat, dude. What's up, guys? What's up, my 13 viewers? Did anybody here find us from not Discord? Like, is anyone here not in the Discord? Did anyone find us from, like, the Explore page or something? I'm always curious if that actually works.
One of my friends, I'm pretty sure I tried to join you. Yeah, you and one of your
I'm from
friends.
Bob.
I'm from Bob. Okay. All right, Ethan. Ethan, I love how you cropped this with your finger, dude. This is hilarious.
How did you know I did this with my fingers?
Because I can tell. That's flesh.
How could you even tell?
It's like he's like doing like this. He's like, yeah, you know, like just it's too funny. Okay. Okay.
I just covered the other two questions up and down.
I like this. Okay. A bridge is 1.25 kilometers long, and at a cost of $7.5 million. What was the average cost per meter? Okay. So they want cost per meter. This is actually a good thing. Anytime you have blank per blank, this is a fraction. Like, for instance, like miles per hour. You guys have seen that one, right? Miles per hour. How would I figure out how fast something is going if it's miles per hour? It's what over what? What divided by what?
Is it miles per hour at the bottom, like the denominator?
No. It's going to be miles on the numerator and hours on the denominator. Okay? That's miles per hour. Okay? So if I have cost per meter, right, what's that going to be as a fraction?
The cost per meter.
How would I write that as a fraction?
And is it in the question?
No. I mean, yeah, cost per meter is here. They want cost per meter. But I'm asking you, how do I write cost per meter as a fraction?
I feel like it's just one simple answer.
Okay, well, remember, miles per hour, right, was miles over hours. What is cost per meter if we do, like, the same pattern here?
Oh, okay, so you put, like, how do you do it? Cost per meter over hours?
No, there's no hours. Good, keep going, you got it.
Yeah, what if you were to just put cost as a numerator and then, what do you call it, meter at the denominator?
Yes, dude. Okay. It's cost divided by meters, okay? Okay, so this is what we got to figure out, Ethan. We got to figure out the cost, we got to figure out the meters, okay? What is the cost of this bridge? What's the cost of the bridge?
Well, it was $7.5 million, so it's like you're saying 7.5.
So I'm going to say $7.5 million, okay? Divided by how many meters? How many meters is the bridge?
That's a long one.
Okay, what does it say? It says it up here, right? What does it say?
I thought, dang it, it's 1/4.
1 1/4. So this is 1 1/4, but this is tricky. This is kilometers, okay? I need to convert kilometers into meters. Do you know how to convert kilometers into meters?
Yeah, you know one thing about this?
What's up?
I haven't even converted units in a long time.
Okay, well, it's good time to review it, dude. Let's review it. How do I convert kilometers to meters?
Kilometers to meters?
Uh-huh.
I feel like it has something to do with a decimal or something.
Yeah, you do move the decimal. That is true. But there's also a number. Okay, what if I say, like, I'm going to give you 3K? Or, like, what is that? How much is 3K?
3 kilometers.
No. If I just say, like, I'm trying to think here. Maybe you don't use that word. Like, K means 1,000. K means 1,000. Kilo means 1,000.
Yes, so what I can gather from that is that, like, 1 kilometer is 1,000 meters.
Yes, good. Okay. So if 1 kilometer is equal to 1,000 meters, okay, how much is 1 1/4 kilometers?
Hold on. This might be a bit tricky. It's like maybe 1,750, like 1,750 kilometers.
No, not quite. Not quite.
It's not kilometers, it's meters.
Well, but it's not kilometers. Well, yeah, it is meters, but it's not 1750. Okay, let's try to write this as a decimal. What is 1 1/4 as a decimal?
1 1/4. Is it like 1.75?
No, that's 1 3/4. 1 1/4.
Really, I forgot.
That's okay. What's a quarter? What's a quarter as a decimal?
It's when you're saying a quarter, it's like a 25 cents.
Yeah, it's good. Yeah, so it's 0.25, right? 0.25, 25 cents, quarter, right? So
Okay.
1 1/4, Ethan, is the same thing as 1.25. Do you see that?
Yeah.
I'm going to multiply that by 1,000, right? Because 1,000 meters is 1 kilometer. Now, when you multiply by 3 zeros, all you have to do is move the decimal 3 places. Right? So it's 1250. Okay? So that's why this many is 1250 meters. Okay? So 1250. All right? That makes sense?
Fine.
Okay. Last
Yes,
thing.
I'm making sense so far.
Last thing. I don't want to do like million of dollars. I want to just do this as like dollars. What would I do this decimal here to get it like in just a number? Like how much is a million?
How much is a million?
Yeah.
When you're saying that, it's like 6 zeros follow behind it to make a million.
Good. Yes. So this is times like 1, 2, 3, 1, 2, 3, right? That's the 6 zeros, right? So if you're multiplying by 6 zeros, then all you need to do is move the decimal 6 places to the right. So we're going to go 1, 2, 3, 4, 5, 6, okay? And then we're going to fill in all these zeros.
Wasn't it 5? Wasn't it 5 or something?
No, it was 6 zeros, right? Because a million is this. This is a million. See 6 zeros?
Yeah.
So you move the decimal 6 places. Okay. All right. That gets you this, right? 7, 5, 1, 2, 3, 1, 2, all over 1, 2, 5, 0, which this, you kind of need a calculator for. Yeah, you do need a calculator for. This is a little big. This is a big question to do without a calculator. Not the Discord. Where's the calculator? There we go. Golden calculator. Okay, so 7, 5, 1, 2, 3, 1, 2, divided by 1, 2, 5, 0, okay? That gets me 6,000, okay? So my cost per meter is, this is going to be $6,000 per meter, okay? So every meter of this bridge costs them $6,000 to make. Does that make sense?
Wow.
Yeah.
Yeah, that's a lot.
It's a lot of money.
Hey, also, remember that time remember that time about my math exam I told you about?
Yeah, what's up?
I gotta go, guys.
All right, good to see you, Mega dude. What's up? About your math exam? What's up, dude?
All right.
I
Bye.
actually did that like on Tuesday.
Okay.
And today's like a kind of a day for
How did
me.
it go? How'd your math exam go, dude? How'd it go?
Honestly, it was maybe the easiest of all
good.
time.
That's dope.
I'm glad it was easy. Glad it wasn't hard.
Maybe I would at least get a 90 something, but they said that like I can't keep it for some reason.
Oh yeah, your teacher doesn't want you to hold the exam because they probably reuse the exam to teach other people is what it is.
Oh.
Okay.
No
Anyways.
proximity chat is in Warzone 2. That's crazy.
Yeah, proximity chat's cool. right. Thank you everyone for coming to Office Hours. Super fun. We'll be streaming again on Friday, hour later. So that'll be 5 o'clock Pacific, 7 o'clock Central, 8 o'clock Eastern. Someone remind me that it's not the time I thought it was.
It is like.
I will.
Hello.
Yeah. What's up? What's up? Bye,
Yo,
Rodneg.
Also, one thing.
Warzone needs a restart to update. That's crazy.
Oh, it does. It does. Okay. All right. All good.
Mhm.
Yeah, Rodneg. Let's do your question next time. Make sure you're not muted or deafened so I can help you.
Oh, and next time we'll do the shit. What was it called? Dark
what?
matter and
Yeah,
other
we do
one.
dark matter and antimatter, and then like, and Shaq
Yeah.
Shaq had a really good question he wanted to ask about about his streams. Like he's like, 10% of the people that watch me stream to me, or sorry, are subscribed to me. Like what percentage? What, and he knows that percentage, so he's like, oh, how many people are actually watching me? And this is a very cool thing with like just inverse fractions.
Yo, that's
yeah.
so complicated. What the hell? I don't
I
even
know, right?
understand what he even said.
Yeah, no, it's pretty cool.
Yeah.
All right, cool. Here. All right, so what we do after recess, after recess, after office hours, after I help you guys with math and science, we play some video games, like blow off some steam and stuff. So, right now, we're gonna play Warzone right now. If you want to play Warzone, Mondays is
Fortnite.
Mondays is Fortnite. Wednesdays is Warzone. Oh, does Warzone have an update? Fridays is whatever.
Yeah.
And then Saturday,
Fortnite too.
Saturday we play
What should we do Friday, actually?
Yeah, we can play Roblox or Minecraft. Like we have a whole Minecraft server, right?
Well, actually,